I don't know about you, but one of the least favorite things about my job is filling in compliance questionnaires such as security and business continuity questionnaires. I know they're necessary, but they all just ask the same questions and just different enough that I pretty much have to start over on each one. So just for a bit of fun, I thought I'd try to take an off-the-shelf AI and give it all my previous answers and then see if you could answer any new questions based on those old answers. I think I probably spent maybe half a day setting this up, and the results are actually pretty decent. So I thought I'd do this little quick video to show you the principles of how it works and then give you the code for those who are interested in that. Hi, I'm Frans. I'm the CTO of NewOrbit. We build bespoke business systems for many organizations, and at the moment we're focusing, as you can imagine, quite a lot on how AI can be used in those business systems to just make companies work a bit more efficiently. So let's get into it. The biggest problem, as I think I mentioned, is that all of the different questionnaires you get, they basically ask the same questions, just slightly differently. So I know of many people who have tried to build up question banks, and in the past it has just never really worked because, again, they're just worded differently. At the same time, trying to take a general large language model such as ChatGPT and asking it to help doesn't really work because it doesn't know your business, it doesn't know your systems. So it's really going to be no use in answering these questions. However, for each question in the questionnaire, if we could find similar questions and answers from the past and then give those to the AI, we can basically say, look, this is what I said in the past to a similar question. Can you please try and answer it now for me with this information, and just sort of adapt it to the way it's been asked this time. Now, in order to do it, the first step here really is to be able to find similar questions from the past. Now, we can use a bit of code and an AI to calculate something called an embedding vector, and then we can store this. So now, an embedding vector is an AI tool that allows us to search based on semantic meaning. What that means is that we can find questions that have a similar meaning even if they're written using completely different words. Now, for this example here, I'm just going to store these vectors in a spreadsheet on your local machine, and that works fine for hundreds or thousands of questions. But of course, if you want to scale up to tens of thousands of past questions, you want to put this in a kind of database such as Azure AI Search or many others. When we then get a new questionnaire, what we then need to do is the following. We read all of the questions with some bit of code. Then for each question, we go through and we find the similar questions from the bank that we created in the previous step. Then we ask an AI to answer each question individually, and we put it all back. And then you need to then manually go through, edit and review this to make sure you're happy with it. And then ideally, you want to be saving those new questions back to the bank so you can use them for the next questionnaire. And that's really all there is to it. Now, just before I get into showing you the code, just let me summarize this. This is really just an example of how the latest generation of AI is really quite cheap and easy to apply to real world business problems. I think we're still in that stage where we're all trying to figure this out, and I think we're all getting quite fed up with the gimmicks like, oh, AI is going to write your emails for you, because it isn't really. The real world requires more nuance, more context than these kind of one-size-fits-all solutions. At the same time, to really get the value of these tools, you need to embed them in your business processes. Now, at NewOrbit, we're experts at building systems that help businesses run more efficiently, and we are helping several of our clients to embed AI into those systems. If you're interested in doing something like that, please get in touch. We're always happy to talk about this. If you're just here for the code, let's get into it. If not, thank you for watching. Okay, so for the code, what I'm using is I'm going to do this in Python because it just makes it a little bit easier to do things in with most AI and data science. I'm not a Python expert, so please, if you are a Python expert, don't cringe too much at the code. I'm also doing this in what's called a Jupyter notebook, which I'm editing in VS Code, and it just means it makes it much easier to show things like this, and you can sort of have text and code mixed in together. Before I start that, let me just show you, I've got the spreadsheet. So this is my amalgamated spreadsheet that I have done. I've basically put all of my previous questionnaires into one spreadsheet, and I've just aligned them so there's a section, which I'll call area, because again, most compliance questionnaires comes with there's a section, and then there's a question. In this case, it's called description, but it's the question. And then the answer in the spreadsheet is called the response. And I've just divided it up into a train set and a test set. That's just because I don't have a blank new questionnaire. So I just took a couple of the questionnaires and I put them in here so I can, have something to try this on. Okay. Now, so the first thing I do is I'm installing some packages. There's like things like NumPy, scikit-learn, OpenAI. That's the package that allows me to talk to OpenAI. That's pretty straightforward. Now, for this particular scenario, I'm just going to use the OpenAI models hosted on Azure. You could use them directly from OpenAI. You could use some completely different models running locally or on Hugging Face or whatever. This is sort of open. You can do whichever you want. Using the OpenAI ones is just super easy to get started with because the APIs are just there. And if you have Azure, you can access them through Azure in a secure way. You just need to set up an environment on Azure for that, which takes a couple of minutes. So I won't cover. So anyway, back to this. So install the shared libraries here, and then I'm gonna this just sets up the API key so that I can use. I've created this OpenAI client that allows me to talk to the OpenAI models like GPT-4 and their text embedding 802 model, which is the one we're going to use for the vectors. And it just allows me to access them really easily without me having to mess around with, hosting AI models in my graphics cards or whatever. Or as I said, if you want to do that, this works just fine with that. So let's run that code. Let's set that up. Now I can talk to it. And then I'm going to create this little helper function. So in order to do an embedding, i.e. create this vector, I need to take the area and the question. I combine them into one string. I send them up to the API, and what I get back, so this is what's sending it up to OpenAI here, and then I get back basically an array of numbers, about 1,500 numbers. I need to do that for all of the questions I already have, and then when I get a new question, I'm going to do exactly the same thing to get the same set of numbers, and then I can compare them, or ask some clever AI to compare them to find the most similar questions based on meaning. So again, just going to run that. For my initial data processing, what I'm going to do is I'm going to open up my input file. That's a spreadsheet, the one I just showed you, and then I've set it up so I only do this if I haven't already done it, just because it can take a little bit of time, and it costs a tiny bit of money to call the OpenAI for this. This is why I'm using Python really, because this is how easy it is to read the spreadsheet into what's called a data frame. So DF is a data frame here. That's just a way of sort of keeping a list of data in memory and mess around with it. Then in this line here, I'm just removing all of the ones that don't have an answer because they're not useful to me. This line here I've commented out, but this is just if you're just testing and want to see it quickly. If you set this up, it will just make you only take the first 10 rows. Now that I have all of the existing questions loaded into memory, this is where the pandas data frame magic really works, because this looks quite magical. But you basically say that create a new column, and then you need to fill it in with this thing, and this is an apply thing. So it basically says for every row that exists in my data frame in my list, run the generate embedding functions and pass it in the section, area, and description, i.e. question, from that row into that function, and then put the resulting 1,500 or so numbers you get back into this field called an embedding, and then save it to a CSV file. That's really all there is to it. And then we have basically built a little database of my previous questions and answers and the embedding of the vector that goes along with it. So let's just run that. And that takes a little while. Now, if you have a lot of questions, there are ways you can optimize this. You can parallelize things. You can send many different texts to be embedded all in one API call and all of that kind of stuff. But because I only have a few hundred, it just wasn't worth the effort. And there we have it. So if you have a look now, I've looked at my previous answer. So this is a CSV file. So if I go to, not to word wrap it, you can see we get, there's a section, there's a question, do you have an enterprise or corporate information security? Here's the answer. And then if you bear with me, I'll keep scrolling here. Then you basically get all of these numbers over here, and that just goes on for a very long time to the right. All right. So once we've done that, now we have a database we can go and look things up in. Okay, so that's a one-off, and once that's done, it's done. So the next thing we're going to do is prepare the inference, and this means prepare to find the right questions back. Yeah, I mentioned that before. I'm only embedding the question. So For my scenario here, I've only done the vector based on the question, not on the answer. Sometimes it might be better to embed the answer as well. You might want to have a little play with it and see. So all this is doing now, this bit of code here basically reads the spreadsheet so that it, that we created before. So just so you can come back and run this without having to do all of it again. And it just does a little bit of converting from strings back into numbers and stuff, which is fine. Now, because we're not using a real database, we are now using an algorithm here, something called nearest neighbors. Basically, what we're saying is this is something that we get set up to say, if we pass in another vector, this thing here, the KNN, will find the most similar previous questions. Probably easier to just show you. This is just code that you just need to know, as it were, but it's not that complicated. So now we've prepared that. That needs to happen every time because it's an in-memory thing. It's like an in-memory database. Then this question here is basically just the thing we're going to use to find existing similar questions. So we're going to use the same. So we're going to get a new question. We're going to pass in, we're going to generate an embedding for the new question in exactly the same way as we did before. Then this is going to find the nearest 5 neighbors. Now, bearing in mind, this is important, the way these algorithms work, you will always get the number of results you specify. It's not like normal search where you can get a variable number of results. You specify how many you want to get and you always get that number back. And that could include ones that are not very good matches, which is one of the downsides to this. There are ways of overcoming that, but So anyway, all this is doing is finding the nearest ones and then just pulling them out and putting them into a list that says, okay, basically adding them in, returning a list of similar questions. Again, easier to show you. So I'm going to just define that. So what we're going to do now, we're going to take an example. So one of the questions we have been given is in an area called Cyber Essentials Plus, and the question is MFA is implemented when available. Now, I appreciate that's not a question, but it's actually a good test because that's how it turned up in our questionnaire. In the question column, it said MFA is implemented when available. So there, go figure. So I'm just going to show you, if I ask the AI to do this, what it's doing and what it returns me. So basically, it says, okay, I have found these 5 questions that are somewhat similar. The first one is, do you utilize multi-factor authentication for connecting to your network? Yeah, that does sound similar. So we're saying the response is, it's hosted in Microsoft Azure, all access required. That's one previous one. The other one is our process procedures, blah, 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 including multi-factor authentication. Now you'll notice here it says multi-factor authentication. Here that said MFA. It understands the difference. The next one is testing automated when applicable and possible. That has nothing to do with multi-factor authentication. That's part of the challenge with this. Sometimes you get incorrect things back. But again, we're going to pass it on to another AI who can hopefully reason about this. Now, the more previous questions you have, the less likely you are to get these kind of problems. If you had, I've probably put 10 questionnaires into that. If I had 50 questionnaires to put into it, it's much less likely I would get erroneous previous questions like this. Okay, now in addition to this, I should mention there's something called re-ranking. So a very good tool you can use is you actually may ask for, say, 10 previous questions, but then you pass those to another AI to say, actually, I know I've given you 10, but I now want you to re-rank them and find the 3 that actually fit the question the best. It's a little bit more of an advanced technique, and it's something that requires you to start deploying your own models to places like Hugging Face or Azure AI Studio or even to your own graphics card. So it's a bit more of a complicated thing, but if you really want to make this really sing, that's a really, really good tool for just making results better. You don't need to do it, but it's sort of the next step up. But I'm going to skip that for today because it's, as I say, it's rather more complex. That was it. Now we are able to find previous matching questions. And just to put that into context, as I say, I know many people in the past who have tried to build these question banks have failed every time. I've just shown you how to do it, and it was not many lines of code, and it actually works. Even if you just had this to find previous good answers, that should already on its own be a good help. Now, so what we're now going to do is we're going to prepare to be able to answer new questions. This gets a bit longer, not more complicated, just a bit longer. So in order to ask any kind of large language model something, we need to give it a prompt. A prompt is basically a set of instructions that explain to it what it is you want it to do. Typically, you don't have to, but you often have a system prompt and a user prompt. It's a bit arbitrary, but in this case, I'm just going to do it. So I'm basically giving it a bunch of information here about using something called the Risen framework to explain, what role it is, what I want it to do, those kind of things. I've given it a bit of information about who we are, what we do, etc., etc. And then I've given it some instructions about, only use information in the prompts to answer questions. That's a good thing because AIs can hallucinate and come up with things. It's a good idea to tell it if it doesn't know an answer rather than just come up with something random. It should just say, I don't know, that kind of thing. Now, I should say this is where I have a little bit of a challenge because NewOrbit builds systems for a lot of people, as I think I've mentioned. So my security questionnaires are across a lot of different systems, whereas yours are more likely to be just for one system. And that actually makes it a lot easier to get good results because my problem is a lot of my answers depends on the system. So when I'm testing this, you'll see sometimes it's not quite right because it doesn't know that different systems behave in different ways. You should not, you are less likely to have that problem. So anyway, the user prompt, I'm basically just saying, look, you're answering a question and I'm having, in my scenario, telling it what the client and system name is so you can go and replace that because you might get an answer back and say, for the Ajax Incorporated system, but in my scenario, it's not Ajax Incorporated, it's Bellwether Labs or whatever. So it needs to know to understand that. And again, that's one of the nice things about the LLMs. They're smart enough to do this, and that is one of the things that makes it so much easier to reuse previous answers and questions. So anyway, I'm passing in, I'm telling it, I'm going to give you some previous questions and answers, which we're passing in, and I'm going to give it the new question. So I've done a couple of little helper functions here to do these kind of things. But the real question here is this thing. So basically, this is the one we're going to use. So given a new question, we're going to find similar questions from the past like we did it before. We're going to just concatenate them into a text string. Then we're going to format the new question. And we are going to then generate this user prompt like this. And then we're going to get the answer. Hopefully that should be fairly straightforward. Now, I'm going to just do that. And then we're going to do a question. So I'm going to take the same question as before. It's MFAs and implemented when available. And I'm going to run that. And that will then, so when I'm running that, that'll go and find the previous questions, pass it to the LLM and come back. And it then says, NewOrbit Limited, who hosts the business system on behalf of Ajax Inc., uses MFA for all backend and internal system access. So that's a pretty good answer to that question. That's basically it. And basically all we now have to do is run that for every question. Again, with Python, that's pretty straightforward. So this is really what we've all waited for. So what I'm doing here is basically saying, look, I'm going to read all of my questions from my test set. Here we go. And read it in. And then I'm going to do the same magic as I did before. I'm going to say, look, create a new column called AI answer. And then for that column, for each one, read the question, pass it into this get answer for a question thing, and then write the answer back out. And then when you're done with all of those, save it out to a CSV file. So I'm going to set that running. That'll take a while. And then, so I'll come back once that's done, and then we can have a look at the result. Okay, so that took about half an hour to do 200-300 questions, something like that. So we can have a little look at it. So just to have a look. So this is the kind of thing we're looking at. So for example, how is data in transit protected? And it says, NewOrbit Limited is blah, 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 uses all traffic is protect encrypted using strong ciphers, that kind of thing. Or, scroll down, say, please describe configuration management, and then it'll say implemented as infrastructure as code, which is exactly the kind of answers we would typically give to that kind of question. So pretty good. Thank you for watching all the way to the end. I hope that was useful. So that's it. This is an example of how to use AI to solve real world business problems. It's not perfect. It doesn't do everything, but it sure as heck makes life an awful lot easier when it's done correctly. Now go have a think about what other kind of problems you could apply this kind of approach to. And don't forget, if you want to have some help brainstorming this or some help building it, we at NewOrbit are always happy to talk. Thank you.